All right, second semester cumulative review, chapter 7. Complete the following statements about the properties of quadrilaterals. Opposite sides of a parallelogram are, I'm going to use symbols here, parallel and congruent. Opposite angles of a parallelogram are congruent. Consecutive angles of a parallelogram are supplementary. Which means they add to 180 degrees. Diagonals of a parallelogram bisect each other. Opposite sides of a rectangle are congruent and parallel. All angles of rectangle are right and measure 90 degrees. Opposite and consecutive angles of a rectangle are congruent and supplementary. I'm going to abbreviate this time right there. We've already written it out. Supplementary. Diagonals of a rectangle are congruent and they bisect each other. Or if you need to hit pause or slow down, feel free to do so. All sides of a rhombus are congruent. Opposite angles of a rhombus are congruent. Consecutive angles of a rhombus are supplementary. Diagonals of a rhombus bisect each other. Remember, that means cut into two equal pieces. And they are perpendicular. That's a symbol for perpendicular. Diagonals of a rhombus bisect a pair of opposite angles. A trapezoid has exactly one pair of parallel sides. The parallel sides of a trapezoid are called bases. The non-parallel sides are called legs. That looks like buses. Bases. The legs of an isosceles trapezoid are congruent. It's like an isosceles triangle. Each pair of base angles of an isosceles trapezoid are congruent. The diagonals of an isosceles trapezoid are congruent. And the mid-segment not the median, the mid-segment of a trapezoid is a segment that connects the midpoints of the legs of the trapezoid. Okay, below are parallelograms. Solve for the unknown variables. Well, a lot going on here. We know that these two are equal to each other. Okay, but without a number, it doesn't really help us. Okay, so we do know that these two are supplementary and those two are supplementary because they're consecutive. So I can say 2x minus 30 plus either x or z, because x and z are going to be equal to each other. Doesn't matter. Equal 180. So that's 3x equals, add 30, 210. So x is 70. And so is z, because they are the same. Now, if x is 70, then 180 minus 70 equals 110. So we know that y is 110. And last but not least, 2x minus 30 is equal to 110. Sorry, we already know that, so we don't have to solve for x there because we already know what x is. W, forgot about those two. For W, this and this opposite sides are equal. So 3W plus 12 equals 6W. If I subtract 3W, I get 3W equals 12, and W equals 4. All right. AE is 3x plus 4. That's right there. Okay. EC is x plus 6. That's right there. Those two are equal to each other because the diagonals bisect each other. So 3x plus 4 equals x plus 6. So I'm going to subtract x and get 2x, subtract 4 and get 2, so x equals 1. Now, it says dB is 4w plus 4. That's his entire thing, dB. EB is this part. That's only half of the entire segment. So 2 of these is equal to this entire length. So that's 2w plus 26 equals 4w plus 4. I'm going to subtract 2w and subtract 4. So w is 11. Again, hit pause if need be. All right, it never hurts to draw a picture. So I'm just going to draw a classic parallelogram. It says W, X, Y, Z, doesn't matter where you put it. Angle X is 4x. Angle Y is 2x plus 60. Find the measure of angle Y. Well, these are consecutive angles. So 4x plus 2x plus 60 equals 180 because they're supplementary. So that's 6x equals 120 when I subtract 60. Combine these two and subtract 60. Divide by 6. X is 20. But it says find the measure of angle Y. So I need to plug 20 in right here. Angle Y is equal to 2 times 20 plus 60, which is 100 degrees. Another way to do that would be to plug it in here. That'd be 80, and then 180 minus 80 is 100. Multiple ways to do it. All right, these two shapes are rectangles. Solve for the unknown variables. Okay. So we know this is 80 degrees right here. And if this is 90, that means W is 10. Okay? And if I have a triangle right here, and I have two 80s, that's 160, that means X is 20. X and Z form a straight line. That means they're supplementary. So Z is 180 minus the 20, which is 160. And Y, remember, these are parallel lines because they're a parallelogram. This is a transversal. We have parallel lines here. If this is 80, then this is 80. Opposite interior angles. are consecutive. That's 80 right there. All right, on 25, again, straight line. These are supplementary, so x is 80. All right, if this is 100 right here, then in this triangle we have 180. That means there's 80 degrees left to be equally distributed here and here, which makes this 40. This is the right angle, so y is 90 minus 40, which is 50. And then consequently, if this is 50, which makes this 40. So z is 40. And then for w, we have AC, which is this diagonal, and BD, which is this diagonal, and diagonals are equal in a rectangle. So therefore, 3w plus 5 equals 2w plus 8. So I'm going to subtract 2w and subtract 5, and w equals 3. Let's just try that over again. There we go. All right, the mid segment. This is in the middle of the two bases. It's the average of the two bases. So we just take 9 plus 15 and divide by 2, which is 24 divided by 2, which means the mid segment measures 12. All right, same idea, except this time we have variables. But still, it's this plus this, so 2x minus 4 plus 8x minus 2 divided by 2 equals 4x plus 6. Two things to do: simplify over here and also get rid of the 2. So I'm going to multiply this whole thing by 2 and this by 2. That gets rid of that. Up top, 8x plus 2x is 10x. Negative 4 minus 2 is negative 6, equals 8x plus 12. So I am going to subtract 8x, add 6, x is 9. And then it asks for ON, which is right here. So that's 8 times 9 minus 2, which equals 72 minus 2, which is 70. Whoops. Okay. Quadrilateral RSTU is a rectangle. If RT is 5x plus 1 and US is 4x plus 8, those are diagonals, which means they are equal. Therefore, I can say 5x plus 1 equals 4x plus 8. Subtract 4x. Subtract 1, x is 7. But it says find US. So I need to plug in 7 right here. So US, 7 times 4 is 28, plus 8 is 36. All right, next one. It says RZ is 2x plus 4. That's this piece right here. And US is 6x minus 8. Okay, well, US is the same as RT, which basically means it takes 2 RZs to make US or RT. So I need to do 2 times RZ is equal to 6x minus 8. So that's 4x plus 8 equals 6x minus 8. I'm going to subtract 4x and add 8, which means x is 8. Then it says find RZ, so that means I plug it in right here. 2 times 8 is 16, plus 4, RZ is 20. All right, last one on this drawing. It says SUT, that's this angle right there, is 3x plus 6. RUS is 5x minus 4. Well, together they form a right angle. So that means 5x minus 4 plus 3x plus 6 equals 90. So 5x plus 3x is 8x. 4, let me just clean it up. Now it looks like 16. 6 minus 4 is 2. I'm going to subtract 2 and get 8x equals 88. Divide x is 11. Now it says find SUT, which means that's the red one here. So 3 times 11 is 33 plus 6. The measure of SUT is 39 degrees. 3 times 11, 33 plus 6, 39. Okay, 31. ABCD is a rhombus. Find the following measures if AB is 5. So if it's a rhombus, this is all, each one of these is 5. So BC is 5, CD is 5, and AD is 5. Look how quick that was. Now the angles. All right. So opposite interior angles, 32 and 3. So this is 32 degrees. Okay. Now remember, the angles are bisected. So this is 32, 32, 32, 32. So that means angle A is 64, and this is 64. Okay, that's 128. So 360 minus 128 leaves 232 degrees to be split up here and here. So that's 116 and 116. But then those have to be split up here and here. So 116 divided by 2 is 58 degrees. And you don't have to do the math because you should know that the diagonals are perpendicular. So it's 90. But if you didn't do that, remember that, and you need to do the math, 56 plus 32 does not work. That's why I meant to write 58. 58 plus 32 is 90 degrees, which leaves 90 degrees right there. All right. It says ABCD, but it's supposed to be, it looks like XY, XWAY. Just a little mistake there. This is a square right there. Don't worry about it. Okay. So Angle 3 is 90 degrees because the diagonals are perpendicular. Okay, if this is 90 degrees right here, these are equal, which means 1 and 2 are both half of that, so 45 degrees. And if 2 is 45 degrees, then 4 must be 45 degrees also, because it forms a right angle. If xt is 7, these letters are all messed up, find xy. Mistake, I didn't see the t in the middle. So here's xt. Okay? That is the leg of a 45, 45, 90 triangle. If this is 7, then this is 7 also, the other leg, and the hypotenuse, xy, is 7 radical 2. If wx is 5, find wy. Well, that is this triangle right here, which wx and xy are also legs of a 45, 45, 90 triangle, which means wy is similarly 5 radical 2. All right, find the midpoint of segment xy if these two are the endpoints. Okay, well, very simple. All you do is add the x's, -5 plus 4 divided by 2, and 8 plus 0 divided by 2. So that is -1/2 and 4. Now, remember, on this one, number 36, you're trying to find the other endpoint. So this is the other endpoint. These two together, divided by 2, equal this one. So 2 plus x divided by 2 equals 9. 6 plus y divided by 2 equals -3. So first step is multiply both sides by 2. So on this one, it's x plus 2 equals 18. So on this one, x is 16 after you subtract 2. And over here, after I multiply by 2, I have 6 plus y equals -6. When I subtract 6, I'm going to get -12. All right, length, distance formula. Remember, I suggest to do this first. So x minus x, -2 minus 6, y minus y, and here's why it's important, because this becomes plus. So -2 minus 6 is -8 squared. Remember, that will be a positive number. 3 plus 4 is 7 squared. That ends up being the square root of 113, which does not simplify. And you can leave it like that. You don't have to turn it into a decimal. What are the ways to show that a figure is a parallelogram? Okay, well, you can say both opposite sides are parallel. You could say both opposite sides are perpendicular. You could say both opposite angles are congruent. You can prove that the diagonals bisect each other, or one pair of opposite sides are both congruent and perpendicular. What are ways to show a figure is a rhombus? All sides congruent, or diagonals are perpendicular. A square, the ultimate quadrilateral, you need to prove all sides are congruent and the diagonals, I'm going to abbreviate that here, are perpendicular. You can prove all sides are congruent and consecutive sides are perpendicular, or consecutive sides are perpendicular and the diagonals are perpendicular. All right, graphing. Q, 3, negative 5. 1, 2, 3, 1, 2, 3, 4, 5. There's Q right there. 6, negative 2. 1, 2, 3, 4, 5, 6, 1, 2. 9, negative 5. 7, 8, 9. 1, 2, 3, 4, 5. And 6, negative 8. 4, 5, 6, 7, 8. What is the best name for that? All right, so the easiest thing to do is get the slope, okay? Count, so from Q to U, so the slope of QU is up 1, 2, 3, right 1, 2, 3. Just one. The slope of DA, the one opposite it, from D, let's go from A. 1, 2, I did something wrong here. No, I didn't. Yeah, I did. 1, 2, 3, 4, 5, 6. Oh, I did not go far enough with my D. It should be down here. I miscounted. So from there, 1, 2, 3 down, 1, 2, 3 left. So that's negative 3 and negative 3, which is also 1. Okay, the slope of QD, I'll just write here also, the slope of UA. So from Q to D, I'm going to go down 1, 2, 3, and right 1, 2, 3. So I'm going down 3 and right 3, which is negative 1. And from A, I'm going to go up 1, 2, 3, and left 1, 2, 3. So for this one, I went up 3, left 3, which is also negative 1. So I know that opposite sides are parallel. This is a parallelogram. To prove that it looks like it's a square, I could do the distance formula on all four sides, or show that the diagonals are perpendicular. Okay, and I've proven also that opposite angles are perpendicular. So I know these are all right angles. So I just need to do the diagonals. So this diagonal is straight up and down. So the slope of UD is undefined, no slope. And the slope of QA is 0, which means those are perpendicular. Now again, I could have done the distance of all four sides, but that's a lot longer. So I'm doing it the quicker way, more efficient. So this is a square. Okay, because the diagonals are perpendicular and consecutive sides are perpendicular. That's the quickest, easy way to do that. Okay, last one. Let's see if I can actually graph these correctly this time. 2, 2. 1, 2, 1, 2. Okay, there's my M. 5, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Negative 3, 8. 1, 2, 3, and 8. There's my T. Negative 6, 2. 1, 2, 3, 4, 5, 6. And there's my 2. There's my H. Nice thing is I have two slopes there I don't have to do anything with. We know they are 0. Okay. So the slope of TA is 0. The slope of HM is 0. The slope of HT and the slope of MA, I'll count those right now. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So the slope of both lines there is 6 over 3, which is just simply 2. I can test the diagonals from T to M. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So the slope of TM is negative 6 over 5. And the slope of HA is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the slope of HA is 6 over 11, not the same. So all we got on this one is it is a parallelogram. Both pair of opposite sides are parallel. And that's it for chapter 8.